Okay, I'll leave this right there. Close that window. Okay, now I have two. Now I have two. 143 seconds, huh? What is this? What is this? Oh. Oh, click. Okay, got it. All right. I'll play with that later. Actually, let's switch this to that. Put the timer back. Put the timer back. I should actually. Good morning, folks. A couple minutes before 11 a.m. on Tuesday, April 7th. I don't know if you, in your part of the state or elsewhere, in La Crosse anyway, we had some not too serious rain, but I could hear the thunder and see some lightning. It all ended before my 7:45 a.m. class started, so that was good. Because I'm like, yeah, I don't know, having equipment fry or yeah, all that like well connected by wires, that doesn't seem like a very good option. So hope you're all doing all right. You got 40 seconds. Yeah. This is my little daily just volume check. It's so strange to just keep talking, just keep talking, and keep talking. Oh, where's the. Okay, right. I gotta wear this thingy so that. Palm rejection. Let's see. There we go. Okay. 9, 8, 7, 6, 5, 4, 3, 2, 1, and hello. Welcome back. I move this over to that screen. All right. Today we are going to continue. Oh yeah, just quick announcements. Quizzes are technically on Tuesdays. I think because of the little bit of delay, you'll notice I'm not like ending class early, and I'm sorry to do that, but like I do want to make use of the time we have. So anyway, quizzes are dated for Tuesdays, but like I just wanted to make sure that people have time. So ideally, if you can just do it today, I think it creates a little bit more of the usual rhythm. But if you need it till the end of the day tomorrow, go for it. Quiz should be on your own. Response due Wednesday, and then homework due Thursday. If you have not started the homework yet, please do so ASAP. I think one of the worst kind of situations people get themselves into is to just start homework all a little too late. So as soon as one homework is turned in, please think about starting the next one. We are on part 2 out of 6 in section 4.8 on functions. So just, I'm not going to overdo the review, but I think we should just write down the key definition was let A and B be sets. Then a function from A to B is a relation from A to B, satisfying, or we could write such that part 1, part 2. So first of all, for each thing, let's call it little a in the domain, there exists something called little b in the codomain, such that f of a is equal to b, but I'm going to write it using the original form. I mean, if you want to write using the new notation, that's cool, but I think right now it's good to see what's under the hood to really think about a function as being a relation. So I'm writing ordered pair belongs to the set. And then part 2, for each, this one's all universally quantified throughout, all three. So for each thing in the domain, for a thing in the codomain. Oh, sorry, not there exists. I was looking a line above. For a thing in the codomain, for anything else in the codomain, if ordered pair AB belongs to F and ordered pair AC belongs to F, then it's because you actually had the same output. So you can't have two different outputs, right? The thing about a function, like vertical line tests, think about like a function as the thing of like when somebody asks, what's your favorite color? Like you're not allowed to have ties. You got to like pick one color. That's what's going on here. The set A is the domain, and capital B is the codomain. Cool. So that's the brief, just quick write of yesterday's definition. I will just comment on a thing that I did not comment on yesterday. Please notice right there, the word there is a, okay, not the. So there are times when either word works. There are times when only one word is appropriate. In this case, it's a relation because there are actually plenty of different relations from A to B. So even sticking with the same sets A and B, there are different, even with the same sets A and B, there are many different relations from A to B that are functions from A to B. So it's inappropriate to say the here because it's, yeah, think about it. Like the means like there's only one. Okay. Just comments that we said yesterday. I won't write them. You'll find them in the PDF if you download that. But yeah, just to remind you, a relation is a special kind of set, and a function is a special kind of relation. Therefore, a function is a special kind of set. The notation, just to review, we saw if you have a function, this is notation for functions, f of r equals s. So this is notation, is just notation for ordered pair Rs belongs to F. So it's this notation that I just boxed that is the notation in the original definition. It's the thing that helps remind you that a function is a special kind of relation, but we are used to some old version of notation. So I know I'm playing a sort of a double standard here of saying, hey, forget everything you knew about functions from before, and yet at the same time I'm trying to use your familiar notation. So I am using language like input for the R there and output for the S, so there is some of that. What I meant yesterday by don't bring in all this baggage of what a function is don't assume that function automatically means continuous function. Don't assume that a function automatically means it has a formula, like x squared plus sine of x, or that kind of thing. That's what I mean by don't make too many assumptions about what a function is. But other than that, I am bringing in the terminology you've seen before. We ended class on this expectation yesterday, and I just want to make sure that we've said this again. When completely defining a function, emphasis here on the word completely. There are times when it's not necessary to completely define a function. You'll see examples in homework. But when completely defining a function, always specify, always state three things. There's a domain, part B, the codomain, and then part C, the rule. So the rule might be the thing provided in a formula version. So as an example, when in like a Calc 1 class in 207, I might write let f of x equal x squared plus sine of x. Okay. This is, so writing, I shouldn't have boxed that yet. Let me box the entire sentence here. Let me even get a period there. So writing what's in this box is the type of thing I totally do in Math 207. In Calc 1, it's appropriate to do. I do it and I feel bad, a little when I do it, because I know that that's not the honest to goodness. It's not technically fully stating a function. It is appropriate in Calc 1, but you're learning the real story is this is only the rule, right? So providing a formula like this is one of the three parts. You got to state a domain and a codomain. So this, just stating this, is considered unacceptable in this class. It's totally fine in Calc 1. I do it to my Calc 1 students. They do it to me. But if you really look from a mathematical perspective, now that we have the quantifier language to talk about it and all this, this is unacceptable to fully define a function. we're missing, this is only part C, right? This is just the rule part. So you need to mention the domain and codomain. And there is I didn't want to introduce too many notational things yesterday. Just wanted you to get used to examples and non-examples. But today, I'm going to introduce a little more notation that helps make parts A and B, introducing the domain and codomain, a little easier. So if the sets A and B are already defined, so that might be as simple as like you had, I'll just put it right in the corner up here, like maybe you had like A is the set of reals or something like that, right? So if you know what the capital A is and the capital B is because you had already described them, then we can use this notation. Again, it's just new notation. It's a shortcut. You can write F colon A arrow B to mean F is a function with domain A and codomain B. So we'll scroll down just a little bit, see if I've got any questions from the crowd. Maybe I will point out a couple things here in a new color, is that this arrow, we've seen a right pointing arrow in the past for like as a notation for the implication symbol, but there's going to be no confusion, right? No confusion with implication. It can't happen because the capital A and the capital B are known to be sets, right? So like if this is why I think it's so important to have a habit, build this habit of every time you see a noun, you ask, what is the thing? Is it a set? Is it a relation? Is it a proposition? So that when you see an arrow between these two symbols, between the capital A and capital B, you don't think A implies B here, because A and B are sets. And sets and propositions are different things. So as long as you kind of stick to that habit all the time, you won't run into those sorts of problems. Also, you might note that we've seen colon in a different setting. That was colon had appeared inside set notation, but there's no curly braces around this thing, so I don't think that's gonna turn into any confusion here either. So just some things to please be careful of. If we go back then to create an example based on the one up here, so this is like what's boxed up there is sort of like considered too informal. So a proper example of writing this down using our new shortcut notation is to write let F from R to R be defined by F equals, and we can write using set notation here, ordered pair X comma well, I don't know, I'll just copy what I've got there, ln of, oh, there's a good reason to do so, ln of quantity 2 plus x squared plus a 3 as x runs through the set of all reals. So here, all three parts, the domain, codomain, rule, are all given in one way or another. So maybe I'll underline those things in another color just for a moment, maybe in green. So domain is there. Codomain is the set that's written after the arrow. So in this example, domain and codomain happen to be the same set. And then the rule is given over here. Right? So this notation is trying to really dig into the original version that a function really is a relation, and a relation is a set. This same example, slightly different notation. We could write let f be a function with domain reals, codomain reals, be defined by f of x is equal to ln of 2 plus x squared plus 3. So these look a little different from each other, but for me, this is describing the same. This is the same example, just written two different ways, right? So one's more the reminding you function is a relation format, and then the other is sort of the more usual function notation you're used to. Um, Again, the real comment I guess to make here, you'll see it in the PDF if you're staring at that along, is looking at that, is you can't skip this. Cannot skip this. You've got to include this one way or another. Now, there are other ways to write this, so you don't have to use the shortcut notation. So, for instance, just to give you some other examples of ways that you could write this, is you could write let f from set reals to reals be defined by, and continue a sentence that way. You could, here's another option, another happy face option, is you could have let, and just make it all part of one sentence, as I think this is the version we just did. Like let f colon r arrow r be defined by, so that works. And then here's a version that technically works, but I'm gonna go with like maybe think about not writing it this way. So let f from r to r be defined by. So see what's going on here is it's a little, to me it's a little strange that the from is written out in words and then the to is written as an arrow. So I I mean it's not, I don't know if it's a technically wrong, but I just think somehow like think about writing a little more stylistically. And that's one of the things that, I mean, the first half of the semester was totally focused on is just the logic right. Like if I read what you're writing, even if it's not written stylistically, is the content there? Like as I read your paragraphs of proofs, like am I seeing, can I reconstruct the flow chart that you had in mind? So is the logic sound? Is the logic correct? But now I think it's time to start, now that we've got some comfortability with that, it's now time to think about some of the style of writing. So, so take a look back here. I've got from and to both written in words, or I've got it all in symbols, using a colon and an arrow. But somehow the mix of the word from with the arrow for to, maybe that's just a little too, I don't know, just a little, somehow stylistically that just seems a little strange is all. Okay, how are we doing there? I'll pause for a moment. See how we're doing. Okay. All right, so just I'd like to introduce a couple new definitions then. So the first one here, so let f be a function from A to B. So this setup sentence is here to say this definition only applies if you have a function, right? So don't try this on a relation. Of course, this first sentence, I'll just put it in a new color. We could have written just much shorter. Let f colon A arrow B. So that's much shorter to write. Your call, personal taste here. So let me continue writing the definition. Next sentence: if the ordered pair AB belongs to F, of course you could even write that using other notation. Then B is the image, there's a new word for us, of A, and here's a second definition as part of this, and A is a preimage of B. So two words being defined here, image and pre-image. And I mean, if you think, like, I know this language of from, to, and I sometimes informally say things like forwards versus backwards. So if like you start with something in the domain, I guess the thingy in the domain, let me circle it in green here, is little a. So you start with something in the domain, then you push forwards, you apply f, you do f of it, so you have f of a, and you get b. So that forwards thing is like called the image. So that's B is the image. B is the output that you have when A is the input. And then going backwards, if you start with B, then a pre-image of B is A. So why is it that A, now sorry about this, this is one of the awful things about handwriting, is that this A right there, that's the A that belongs to capital A. This A that I'm pointing to right now, this is the word, right? This is the English word A. Now, I'm going to pose this to the whole class and ask somebody to unmute and answer, why is the word A there? And I do have a hand raised, so I'll take an answer to that question or just a different question or whatever.
I was actually just about to, I guess, ask the same question you just asked. So, um, I
Yeah.
guess it was supposed to be a question that we asked.
Yeah.
I
No,
didn't have an answer to
no. Okay,
it.
okay. Well, good. Well, I'm glad. I mean, even if all you're doing is asking the question I was about to ask, this is perfect, right? Like you're thinking about the things I want you to think about, and I think part of this is it's a story. Like in the first half of the semester, I let go of a lot for A versus the because I had much larger battles to pick, right? So if I scroll back up here, take a look at over here. It was A and not the because there are many relations from A to B that are functions. I mean, not all of them, but some. They've got to satisfy properties 1 and 2. And then over here, what's going on? So let's wait. I just maybe everybody can think about it. Okay, I'm getting a response. So Mitch, thanks for the question, but I'm getting a response from Hannah that because there can be more than one preimage of B? Question mark. Maybe y'all see that in the chat as well, and that is precisely it. There can be more than one. Jazz, you had a hand up as well. I'm guessing it was the same. You just lowered a hand, so I'm going to assume it's that.
Yeah, I was going to say the same thing.
Okay, yeah. So that's what's going on here. If I just I don't have it in my notes. I'm just going to make a real brief example, just off to the side to illustrate this. So I better follow my rules and mention both the domain and codomain, and then mention the rule for the function. But you'll take a look that let me state it this way: that 25 is the image. Emphasis on the word "the" is the image of 5. However, 3 is a preimage of 9. And it's important to say a preimage because it's not the only preimage of 9. -3 is another, is a preimage of 9 as well. So does that, Mitch, clarify the... I mean, I guess it's for the whole class, but it was Mitch's question and my question at the same time.
Yeah, that makes sense. Yeah.
Okay. Yeah. So even in a short 2-sentence definition here, that's the first sentence is really just set up. So the meat of all this is in the second sentence, and you're noticing like there's an A and there's a the. Again, I'll circle maybe in red right now the grammatical A and the grammatical the, and I think in a very technical sense, it's helpful to use the correct words, right? Like you never thought maybe in a math class you'd focus so much on A and the, but like I think as Rafi brought up yesterday, this questions of like existence and uniqueness. So uniqueness, it's really honestly helpful in any kind of STEM discipline to know whether you have one of something or whether you have many of something. So let me switch back to black for the color. Okay, and then one other thing, we're gonna informally. We're going to informally say, so in the situation that we have above, we'll also say the following. We'll say F maps A to B. What I mean by informally is I'm sure in some other books in the area, there's a formal definition that says like, let F be a function from A to B, and if ordered pair AB belongs to F, then we say F maps A to B. The thing is, at some point, you can have just too many definitions. So I mean informally to say, like, I'm never going to quiz you on this word maps like this. I'm never going to include it in an exam or a quiz. Not like this. Because it's just too many different vocabularies, I guess is the point. But, like, you might hear me talk this way accidentally. I might say, like in our previous example, I might say that F maps 5 to 25. I might just use that language because it's informal. It's easy to speak like that aloud, and I almost prefer that I didn't use that language just so that we had fewer ways of saying the same thing, just so that I don't overdo it. But it's a habit, right? Like, and maybe it's actually okay for you to hear that way that people speak about it, because there will be people who speak about it that way in the future to you. So, all right. So let's see. I'm going to introduce. So actually, I was going to skip this, but I think it's better to just include it. So in our earlier example, in the last example, you would note that we had the ordered pair 4 for the first coordinate and ln of 18 plus a 3 for the second coordinate, that this belongs to f. Let me scroll up just for a moment. Not this example, I mean back up here. Let me just copy, paste this example down here so that you can see it. So yeah, in this last example, right? Because as you run through every single real number and call it x, then you get an ordered pair where the number you picked, x, I picked a 4, clearly, comma, ln of 2 plus 4 squared plus 3, that's an element of f. So in the example from this function, if I had a board, I wouldn't be needing to do all this copy-paste shenanigans. We had this ordered pair, and just to hone in and practice the language, we would say ln of 18 plus 3 is the image of 4. However, 4 is a preimage of this number ln of 18 plus 3. Okay, and it is a preimage because I'll leave it to you to think about, but there's actually another preimage of ln of 18 plus 3. All right. One more notation, and sorry to introduce it, but it's just it's a way that people do things. So if you're dealing with one math problem or one proof or one exercise or whatever, and there's only one function, if a problem or proof has only one function, so spoiler alert, I mean, you can have a proof that deals with more than one function, just like you've dealt with proofs that deal with more than one set, A is a subset of B, that kind of business. But if there's only one function, there's actually a neat notation you can use to leave out the name of the function altogether. So, I'm going to introduce 3. You've already seen 2 notations. So there's the original notation, like ordered pair mn belongs to f. Let me box that. That's one way to say it. That's sort of reminding you functions of relation. We have the usual function notation from like Calc 1 class, f of m is equal to n. That's another way to say it. And there's a new lazy notation to use when there's only one function. So you don't even have to mention f, but you've got to be careful in how this notation looks. It's m and then a special kind of arrow that has a little extra vertical stick attached to it, and then n. So this is notation that's used. You can see why you have to have a problem or a proof or whatever that only has one function in it, because the function name isn't even here at all. So this is just a third. All 3 box things to me are read exactly the same. Its input is m, output is n. This symbol, if you want this in LaTeX, it is \maps2 as one word. So it's kind of nice. That's why I wanted to cover that informal language of m maps to n. So it reads off okay. So if we look back to our last example, continuing it, using this third and new notation, we could write 4 maps to ln of 18 plus 3. So it's just a third notation that's sometimes useful. I should just comment for those who enjoy computer science in the audience. If you're not a fan of programming, just tune out for just a second. But I wasn't going to say this, but just a fun detail. This maps to like notation is actually great for one. If a computer science professor is probably going to laugh at me, but one paradigm of programming. So by paradigm, I'm probably not using the right word, but I mean like there's procedural programming, there's object-oriented programming, database programming, and so like kind of one major frame of thought of programming is to think of your functions, your user-defined functions, the way a computer scientist says a function, um, in a format where you don't even name your function. And so you see here, there's not a name to the function, and that brand or style of thinking about doing programming is known as Lambda Calculus. Don't ask me much about it. I actually, as an undergrad, took a class. It was CS 61A. Still is burned in my memory. It was a fun and very difficult class that was focused on a Lambda Calculus approach to programming using a programming language called Scheme, which is a tail recursive dialect of Lisp. But whatever, that's too many details. Okay, I'm off the computer science rant for what? Not rant, just little fun detail. Actually, yeah, one more thing. Lambda Calculus is actually a really awesome way to think about what's going on in programming, but maybe that's all I'll say about this. Okay, back to the regularly scheduled program. So, definition, let f colon x arrow y. So this, of course, you could write this out in more words, but in this short sentence with a lot of notation, I'm saying you got to have a function from domain x to codomain y. And the new definition here is the range. I wanted to get this definition in as early, in a sense, as possible, because it's different from codomain. If you want to clarify what this is as part of a larger phrase, it's the range of f. So the range of f is curly brace, f of s, vertical bar or colon, your choice, x, element of x. Cool, there's that definition. So stare at this definition for a second, and you ought to ask yourself, things like noun, adjective, verb, and I hope you said noun. And then every time you have a noun, you ought to think to yourself now, is the noun I have, I know in the early part of the semester, every freaking definition that was a noun was just a proposition. So you're like, what's the big deal? But now you notice we've got proposition versus set. And then even if you have a set, you should go, is it just a set that's not a relation? Or is it a set that's also a relation, but not a function? Or is it a set, relation, and function? Like all those things. So F, you'll notice, there's the definition already. I've just used color, but the F is a set, relation, and function. This thingy over here that's being defined based off of F is not a function. It's just a set, right? It's just a set because of the curly braces. Take a look at how it's written. It's written using not the set builder with criterion notation, but it's using that build a set running through another set. So this notation is actually super convenient for getting an intuitive idea of what belongs to the set. So, think about it. So every time you pick an element from capital X, and just so that I can refer to the choice, let's call whatever you chose little s, then you F it. Okay, yeah. Giggle. You F it. But you apply the function F, right? So you take that domain thingy, little s. Each time you have a domain thingy, you apply F. In other words, you ask what's the output when the input was S. And basically this set, so I guess informally, what could we say? I think we could say that this range thingy is a set that collects together as its members all of the actual outputs you get for the function F. Does that work? Notice how that's somewhat different from the codomain. See, in the original definition of a function, there was just the promise or the let's say the requirement to be a function in part 1 was that for each thing in the domain, there exists a thing in the codomain. But maybe not everything in the codomain ends up actually being an output. The range is really the set of all the outputs. Just as a remark, I'll pause actually, just see, are we okay so far? As a remark, The range of f is also called the image of f. So in books on introduction to mathematical proof, sometimes some books use the word range, use the phrase range of f. Other books use the phrase image of f. Some books, in a sense, use both. I think I'll just try to stick to range as much as possible here because of what we're going to look at next. Before moving on, just since it is in my notes, I was just thinking that you ought to work on it, but like let's think about converting this set. So this range, I'm just gonna informally create a notation, range of f like that. But look up here, boxed in blue, the set is written in this format. So I want you to take a moment to practice by writing the set in the other notation. So I'll give you a moment. Okay, so you've got to choose some kind of variable to serve as a placeholder. It does not matter what letter you pick. I would just not pick a little s because that's already up there. So how about I'm going to go with a t, and the property that follows after the colon ought to be there exists, and then you quantify based on what's behind there. So there exists little s and capital X such that and then the placeholder variable t equals, and then the text that was before the vertical bar or colon. So this f of s. Of course, what you wrote might look a little different because you didn't use little t's. I didn't tell you what letter to pick. So if the two little t's you wrote are little m's or little q's or whatever, that's fine. I will also say, even though this was directly converting this, I'm going to include one other detail in that we know whenever you have a thingy at like little s that belongs to the domain, and when you apply f to it, you get something in the codomain, right? So this t, if f of s belongs to the codomain, and the codomain just from up here is capital Y. So if f of s belongs to capital Y and t is equal to that, then t belongs to capital Y. So I'm actually going to go ahead and include this extra information and have here, oh, this was not a good idea. We'll just keep it there. I'm going to include, it's not part of, this piece of the exercise, I wasn't expecting anybody to do it. And it's not part of the standard way of rewriting the set, but it's just applying the information that we have to note that t happens to always belong to the codomain, and I'm just using the codomain that was stated up there, just to connect some pieces together and remind you some of what the definition of function's giving. Question from Hannah: could you say that the range is a subset of the codomain? Yeah, you stole my thunder. Thank you. That's the okay. So that's actually the next comment is to note here. Thank you, though. That's the right thought. So here the thing is, whenever you have a function, for any function, the range of f is a subset of the codomain of f. Oh, I guess I should have said for any function f. For any function f, comma, the range of f is a subset of the codomain of f. And you can prove this. You can prove this statement. You know, standard proof techniques do that. And what I also think is kind of neat is we're getting to that point in the semester where we do have a lot of terminology. I get that. But what's kind of neat is now the questions that I'm seeing from people are being formulated using our terminology. And that's a fantastic thing to start to do. So I know sometimes we get in this, and every time you see a new definition, it's hard to work with it at first. And that's why there's a struggle of working through things in homeworks and so on. But once you start feeling how a definition plays out from doing some proofs, I would encourage you to, even if you don't ask questions aloud in class, I want you to try to keep thinking, form your sentences using all the new words that you get. That's a helpful thing to do. Okay, Let's see. Yeah, so give that a proof on your own at some point. What I'd like to do, though, is introduce another definition that looks super similar. So today, I'm sorry for, in some sense, the number of definitions, but let f be a function from domain x to codomain y. One additional setup sentence here. Let capital S be a subset of capital X. So you need a subset of the domain. Then the image of S, often this is good enough. If you need to clarify which function, then people use these kinds of awkward phrases like under F. Okay, if you left out the under F, most of the time it's probably going to be fine. There's usually only one function. Is. And then I'll introduce here the notation. So f of capital S. I know this looks funky. So we're applying the function to the set capital S. And I don't want you to think of it like that. Just call this notation. It's funky notation. So what is it? This is notation. And what does it notation stand for? It stands for this set. F of little s runs through capital S. So there is a new definition here. I know this sounds strange, but like compare this to the definition we just looked at. Compare this to the definition of range. So it's already up there, but I'm just going to recall this. The range of f was the set f of s, where s ran through all of x. So let me actually, in fact, just shift where this is written a little bit. Right, so I tried to write just directly underneath. Do you see how similar these are, right? So you're this both of this new thingy, the image of S under F, and then the old thingy, this range of F, they both are the elements are f of s's. So as you run S through a certain set, you just each time you run through an input S, you just see what's the output and collect these outputs together inside a new set. Just the difference is what set do you run through, right? Which inputs are you taking? Well, in the case of the range, because it's a capital X there, you run through the entire domain. And because over here in this new definition, it's S, which is a subset of X, you just run through a certain part of the domain. What part? Well, that's provided by S. Remember, that second sentence is a setup that you have to provide an S to begin with. Okay, so we can also practice rewriting this set. So f of s, again, this is written, the format as given in the definition is meant to help with intuitively understanding what belongs to the set, but for proofs, it's actually more useful to convert the set. And again, we learned earlier that the elements would belong to y anyway, and so this should be there exists an s in capital S now is the difference instead of a capital X, such that f of s is equal to t. Okay. So I would say this version is convenient for proof, but don't memorize it that way. It's much easier to memorize it this way. And just, I think the other thing is sometimes people try to memorize like what's inside this blue box word for word or symbol for symbol, and I don't think that's the way to go about it. The idea here is you've got a subset of the domain, and you just apply f to each of the things in that subset. And then it's like part of the range, right? It's just, you just want to know the outputs for these specific inputs. And by these specific inputs, I mean those inputs that belong to the set S. That's all that's going on here. Sometimes people kind of overdo what's the memorization instead of stopping to just kind of go understand like what this is trying to be in a nutshell. I will also comment, because I think sometimes a confusion occurs. When you see f of little s versus f of capital S, right? So you see it like Let me circle this in red over here. So you got an f of capital S and you have an f of little s. First of all, don't assume that a little thing is always an element and a big letter is always a set. After all, little f is a function and therefore a set. So I think in all times, what you need to ask yourself is the thingy that's in parentheses. Whether it's a little s or capital S, don't read too much into the capital versus lowercase, but go, is this thingy an element of the domain or a subset of the domain? So if you have an element of the domain, then think of this as little f of little s. If little s is an element of the domain, then we're talking about the image of this element, right? Like what's the output? If you have f of, and the thingy in parentheses is a set, is a subset of the domain, then you have to apply this new definition here, right? And then you've got to go, okay, I've got to apply f to each of the elements of the set. So I'd like you to practice. If you just look in my PDF, you would just steal the chance to practice. So don't look there. I want you to just, the answers are there, but I want you to take this function I'm introducing. The domain is a set of these 5 integers, 1, 2, 3, 4, 5. Codomain is reals. So I'm trying to form my good habits and model that for you. I've stated my domain and codomain. I need to tell you the rule. And the way I'm going to tell you this rule is, since there's only 5 things in the domain, I can just tell you the 5 ordered pairs that belong to the set. So ordered pair 1, comma pi, ordered pair 2, comma 2, ordered pair 3, comma pi, ordered pair 4, comma negative 8, ordered pair 5, comma 5 halves. Okay, so this completely defines a function. I would like to ask you, please, to take a moment to find the domain. That's part A. Part B, not even find, just state, I guess, right? There's not a whole lot to do here. State the codomain. Part C, state the range. Try to write the range in as simple of a format as possible. Part D, let capital S equal the set 3, 4. Then find f. I hesitate to even call this. I don't want to say find f of s. I'll put this in words as well. This is find the image of capital S under f, to use the language that was introduced. And then finally part E, let capital T equal set 1, 3. Find. Again, I don't want to call it f of t, although if you did, I wouldn't blame you. So give you a moment to try all 5 parts of this, and then we will chat for a little bit. Okay, I'm going to write my answers in a new color. So first of all, the domain, we didn't name it like a capital A or anything, so I think I'm just going to write it like that. Right? The domain is that set. The codomain, reals, right? Is the set that the arrow is pointing to. The range, so this is about applying f to each input in the domain. So what is f of 1, and what is f of 2, and what is f of 3, and what is f of 4, and what is f of 5. And so I'm not even looking at my notes. I'm just kind of staring over here at the rule where I just pointed the blue arrow, and I'm noticing pi is an output, and then 2 is an output, and pi is an output. You could write pi again if you want, but repetition doesn't matter in a set anyway. So you could write it or not. It's not wrong or right to write it a second time, but I'll just add a laziness. Pi, comma 2, comma -8, comma 5 halves. You can write this in any order. The cardinality of the range is 4. Right? There's 4 elements in the range, even though there was 5 elements in the domain. And that's, of course, because there was a repetition, wasn't there? Right? Two different inputs had the same output of pi. Part D, I'll write down here. So we need the image. This is asking just f of capital S here is just really asking what are the outputs, but not all the outputs. That was the range. Just the outputs for those inputs which belong to S. In other words, we're just asking, take a look at S. What is, the inputs right now, we're only dealing with input 3 and 4. Not all 5 inputs, just input 3 and input 4. And what are the outputs there? And those outputs are pi and -8. And collect those together in a set. Right? So of course, there's a more generic way to write what this image is based on what's up there in the definition earlier. But like, to write this as really down to earth as possible, to compute and write something very specific to this problem, I would say we write this in a comma separated form like that. And then part E is the same general style question. It's exercising the same definition. It's if you only look at input 1 and only look at input 3, what outputs do you get? Collect these all together in a set. And the only output you get is pi. What I just wrote is incorrect. You can't just have pi the number. You've got to have a set. So this is a singleton. I'm going to pause. See, are we cool with this? Are there any questions of any kind? Okay, I think this is the most important in-class exercise we have done so far. I cannot, maybe I don't want to, maybe I'm overstating or something, but don't forget this. And what I'm trying to model is a thing you should do every time you see a new definition. Make a little example, practice, gain some intuition for what's happening. And this will come up all the time. I know because this is the 4th time I'm teaching 225. Even 2 weeks from now, I'm going to have a problem in a homework, and I'm not trying to trap anybody, but I just have some problem where there's a function that I provide for you. I provide the domain, codomain, and rule, and I state a set like this, and then you need to deal with f of capital S in another part of the problem, because maybe you need to prove that this is a subset of some other set, and people just kind of let go of the definition altogether and go, I don't know what I'm, so go back to, and whenever you're stuck in a proof, it's usually a certain definition that needed to be applied wasn't applied. The only other thing that I could think of is, maybe you need to prove a for all and you didn't address how do I prove a for all? It's those sorts of things. So just please don't forget the definition of image. It's an easy one to forget. So it'll happen, but I'm trying to say come back to this moment. Now for an interesting, very maybe strange warning. Please understand that there's a difference between f versus f of x. I know this sounds ridiculous, perhaps. When I teach calculus, when I teach college algebra, I say f and f of x interchangeably all the time. It's an error that I make because it's appropriate to make there. It's another place where I can't pick that battle in teaching Math 207 or Math 151 or something like that. Here, it is absolutely critical. I know this sounds strange, but f is a function. Okay, so these are different. I cannot. You're going to hear me repeat this one often, unfortunately, because it's just people make the error so often. So sorry in advance. This is a function, and then this other one, f of x. This is an element of the codomain. This is an element of the codomain. I mean, as long as if x is in the domain. This is really critical. So I want to dig into this warning by example. So I'm going to state for you a function. So f is this function the domain consists of 3 elements, 7, 8, 9. The codomain is a set of all reals. The function, since there's only 3 things in the domain, I don't need to provide some formula thing. I'll just provide the 3 ordered pairs. So 7, 2 ordered pair 8 pi, and then ordered pair 9 comma root 5. Okay, so notice that each time you have one of the 3 domain elements, the output, or the second coordinate, happens to always be a real number. Okay, so this is a function. So just to compare the difference between f versus f of x, right? So f is the function, or really, in the end, f is the set. So let me underline it in a new color, right? So f is that. F is a set of 3 ordered pairs. In contrast, f of x, or just let me pick a specific x, f of 9 is an element of the codomain. In this case, the codomain was reals, so I'll just write reals there, right? F of 9 is an element of the reals. Specifically, in this case, what element of the reals? It was root 5. That's an element of the reals, right? So do you get what I mean? F and f of 9 are different, and so in general, f and f of x, even if x is just some variable, like we gotta be really careful about the language here. One of these things is a set, right? The function over here, just the letter by itself is a set, and then f of blah, that is an element of the codomain. So I think you're going to see, and we're going to end the class on this definition, and we will pick this up tomorrow, but I needed to state this warning before this definition. So just as like a teaser to start tomorrow's class, let me write this definition down so you can think about it. So let f be a function from A to B. A is the domain, B is the codomain. We say f is injective. So injective is one word that is used here. Or another word that gets used is one-to-one. F is injective or one-to-one. So some books prefer one of these words versus the other. I'm going to try to get you used to both of them. If, please remember that the first if you read in a definition is technically, it operates like an if and only if. If for all x and y in the domain, if f of x equals f of y, then x is equal to y. Now, tomorrow we will spend some time interpreting what the heck this means. So you're sort of not homework, but just something that you can chew on is, what does this mean? Try to pick this apart and put this in some more everyday language if you can. But the connection, the reason I wanted to end class on this is I want to connect it to the warning real quick. So back up here, we had f versus f of x. Take a look. It's f right there, and then you've got like an f of x right there, right? So both appear, and I'm using these appropriately. F without the of x is a function, and this word injective is an adjective that you can apply to functions. So it's appropriate over here to just have an f, because that's the function. And then over here, f of x, which I'm trying to underline right now, that's an element of the codomain. So try to sort out for yourself what the heck this new definition is trying to state. And I will see you tomorrow. Don't forget to turn in the quiz either today or tomorrow.